Okay. So solving systems of equations, no matter what method you use to solve it. So we're going to use graphing this week, and then when we come back after Thanksgiving, we're going to do some other methods of solving systems. But by graphing, there are three possibilities. Three possible outcomes. Bless you. Okay. The first possible outcome is one that happens the most for us in this class and pretty much any algebra class you're going to take in high school, is that there's one solution. One solution is also called consistent and independent. So if we're looking, those are kind of the more math terms for one solution. One solution, consistent and independent. Consistent and independent for one solution. Another scenario that could happen is that there not be any solutions. And that's called inconsistent. So if it's got an answer, it's consistent. If it's only one answer, it's consistent and independent. If there are no solutions, it's called inconsistent. Inconsistent system. No solution. We're going to see what that all looks like in just a minute with this. The third scenario is that there's infinitely many solutions. Hayden, could you reach over and turn that air off? That's called consistent and dependent. Okay, consistent and dependent. So if it's got answers, it's consistent. If it's only one answer, it's independent. If it's multiple answers, it's dependent. Infinitely many means it's got a bunch of answers. Okay. If it has no answers, it's inconsistent. Okay, so that can help kind of tie those together. So these three scenarios can happen when we're talking about systems of equations, no matter what method you would use to solve them. So we're going to use graphing today to solve them. We'll learn a few other methods in Chapter 7 before the end of the semester, and then in Algebra 2, you learn even more methods for solving even larger systems out of this. So our systems are going to be something like this. So we're going to start with something easy, like y equals negative 1/2 x plus 7. And the second equation is y equals 3/2 x minus 4. What form are both of those equations in? Slope-intercept form. That's the form we want them in if we're going to graph. And that's what we're going to use to solve these, is graphing these systems. So we're going to graph both of these equations on the same coordinate plane. Okay, so and see what happens. So I'm going to draw myself a little coordinate plane here. I got to go up to 7 on the y-axis and at least down to -4 on the bottom side of it. So I'm going to make sure I got room. So I'm going to graph the first one. I'm going to draw a red line for it. So I'm just putting a big red dot there. So this is the red one. So where do I start with this one? At 7 on the y-axis. So 1, 2, 3, 4, 5, 6, 7. There's my first dot. And then how do I count that slope? Down 1, right 2. Down 1, right 2. If you wanted to, you could go up 1, left 2. Same thing, okay? And we're just going to draw that line. Try to follow that and be as precise as you possibly can. Now we're going to graph the second equation. I'm going to use a blue line for it. Where do I start with that one? At -4 on the y-axis. Now how do I count that slope? Up 3, right 2. I can go up 3, right 2 again. Go up 3 and right 2. Again, 1, 2, 3, 1, 2, 2, 3, 1, 2, 1, 2, 3, 1, 2. And I'm going to draw that line. Notice I kept counting my slope until I crossed the red line. That'll help you if you'll do that. It's not something you absolutely have to do, but it sure does help get things a little bit more accurate and more precise. Okay. Now, how many places does the red line and the blue line touch? One. That's one solution. Okay. That's what that means. One solution means one place where they're going to cross. That solution has an ordered pair. This one's not at a really perfect place, but where they cross is where their answer is. So it doesn't always happen at a nice, perfect place. We'll see some that do. So if I look at that, I count on my x-axis, 1, 2, 3, 4, 5. It's a little past 5. It's about maybe 5.5. That's where mine looks like it is. 5.5 on the x-axis. The y-axis, it goes up 1, 2, 3, 4, about 4.5. And that is the solution, approximately, for our system of equations here. Somewhere around there. I think your book does a better job of picking equations that end up at nicer places. But it's not a necessity that they end up at a nice place. Okay, but where they cross, if they cross, they got one solution. If they don't cross, how many solutions do they have? None. Okay, so there's a difference in one solution and no solutions. Infinitely many. What do you think that's going to look like? It's going to touch in a bunch of spots. But if they're straight lines, what's the only way that can happen? Right on top of each other. That'd be the only way that two lines, like these markers, could represent lines. The only way they could touch at infinitely many spots would be if they lay right on top of each other. Because if I like that, they're only touching in one spot. Parallel, they're not touching at all. Smashed together, they're touching in a lot of different places. Okay, so that's where the difference in that. And we'll see some examples here today, what that looks like. So let's look at example B. And let's say we had negative x plus y is equal to negative 7. And then x plus 4y, equals negative 8. Okay, so are those in the right form? No. So we need to get them in what form was it? Slope intercept. So for the first one, what do I need to do? Add x. So that's going to get into the form y equals x minus 7. If I add x to both sides, that's the operation that makes that happen. Get y by itself. That's the key. So the first one is y equals x minus 7. That's in the right form. We're good with that one. So let's get the second one there. How do I do that? Subtract x. So that'd give me 4y is equal to negative x minus 8. Divide by 4. What all gets divided by 4? Everybody. That's going to be y is equal to negative 1/4 x minus 2, right? Because there's like a negative 1 in front of x. Divided by 4 would be negative 1/4. We're going to leave that as a fraction. 8 divided by 4 is 2, and it was a minus sign. So now we have those in slope-intercept form. These are the two we're going to graph. So let's graph those on the coordinate plane. See if they cross or where they would cross. Do we know if these are cross or not before we even start? They have the same slope. What's the slope of the red one? Positive 1. The slope of the blue one is. So the slopes are not the same. So that means they're not what? They're not parallel. And parallel lines never cross. Remember, parallel lines are lines that never touch. Okay, so we know that these are not parallel. So that means they should cross out of that. Okay, so I'm going to graph that red one. Start at negative 7. Up 1/1. I just did several dots there just to get a good, as straight a line as I possibly can. Okay. Then the blue one, where's its y-intercept? -2. Down 1 over 4. Hey, man, that landed right on it. How many solutions do we have? 1. So this is consistent and independent. That one solution is right there. I'm going to count that. What's that spot? That's 1, 2, 3, 4. 1, 2, 3. 4, -3 is the ordered pair where those two cross. So we're on the graph finding where these two cross. That one ended up being at a nice place, which most of them you'll have in this section are. So graphing a line in slope-intercept form is going to be key to doing this section. Let's look at example C. Say we had -5x plus y equals 0. And then the second equation is +5x plus y equals 10. Are those in the right form to graph? No. Let's get them there. So how do I get the first one there? Add 5x. That's going to give me y is equal to 5x. Technically plus what? 0. We normally don't write that. Okay. The second one, what do I do to get y by? Yeah, it's -5x. So that's going to give me y is equal to -5x plus 10. Those in the right form now? Yeah, so I'm going to graph them. So what's the y-intercept for the red one? 0. So starts there. What's the slope? Y equals 5x. What's the slope? 5. So go up 5 over 1. Do one more there. So there's the red line. Get the blue in there. What's the y-intercept for the blue one? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Slope. So I'll go down 5 over 1. Hey, it's up right in a nice little spot where they're crossing. One solution at 1, 5. X value, go over 1. That's where that's at. And then it's 1, 2, 3, 4, 5 up. 1, 5 is the solution for that system of equations. One solution, they're going to cross. That's what we should be getting out of this. They're going to cross if there's one solution. Y equals 1/3 x plus 7, and y equals 1/3 x minus 3. Are those in the right forms? What do we know about those two equations? They got the same slope, so we call that what? Parallel. We know they're parallel, and they're not the same line because the y-intercept's different. So the graph is going to look like, I'm going to graph the first one red, +7 of 1 over 3. There's the red line. Oops, maybe not that bad. There we go. And the blue one, I'll go to -3 and do the same slope. Those two would never cross. They have the same slope. They're parallel, so that would be no solution. Or inconsistent is the mathy word that goes with that. Inconsistent or no solution. Example E. Y equals -3x plus 4. 2y is equal to -6x plus 8. Well, one of those is okay. All right. So on this second one, I'm going to divide everybody by 2. That's going to give me y is equal to -3x plus 4. What do we know about these two equations? What about them? They're exactly what? The same, okay? So if I graphed each of them, I'm just showing you what the graph looks like. I think we all see that, hey, if it's exactly the same equation, then it should be which of the three possibilities? The infinitely many solutions possibility here, because they're exactly the same equation. So when you go to graph those, if you graph the first one, that's the line of the first one. The second one, you go to do the same thing, and it lays right on top of it. You got the red line and the blue line right on top of one another. That's why that is infinitely many solutions. Because they're the exact same line, they lay right on top of each other, and they're touching everywhere you see red and blue touching, those lines are touching. Okay, so that's infinite number. We couldn't count how many there are. That's what infinitely many solutions means. Okay. So we got one solution scenario, 3 of those we did, and then we saw the no solution scenario where it's parallel lines. And then here we have the infinitely many solution scenario where it's the exact same equation twice. So hopefully my thing is, if it's parallel, should you even have to draw the graph to find the answer, to tell me that it's no solution? No, if you know that the lines are parallel, then it's no solution. There's no sense in graphing that. If it's infinitely many solutions, is there any point in graphing this really? No, because it's the exact same line, so it has to be infinitely many solutions. So it's not going to benefit you to graph those. Okay, so look for those situations. If they comes up where it's parallel lines, then just say no solution. You don't have to draw the graph. If it shows up in their exact same equation, it's infinitely many solutions. You don't have to graph that. Okay. All right, let's get just one more here, and then it'll be time for lunch, and this will be the end of the lesson, believe it or not. So it's really short. So here's our equations. 5x equals 10, and 3/4 y equals -12. Those are a little different. Yeah, that'd be a good idea. The only variable in the top one is x, so let's just get it by itself. So if I divide it by 5, I get x is equal to 2. What does that look like if you go to graph it? It's a vertical line. Yeah, that's what it is. It's a vertical line that goes through 2 on the x-axis. And then what? Yeah, we could multiply by 4 and then divide by 3, or get it in one step and multiply by 4/3. The reciprocal there would work. And you're going to get the y by itself here because we don't have an x. And then maybe 1, -4. So that'd be -16. So -16 is way down here. I'm not going to have room. So I'm going to change the scale on my y-axis to going by 4s. So that this is -4, this would be -8, -12, and then there's -16. Horizontal line going right through there. How many solutions? 1. They weren't parallel. We knew that, so there had to be a solution. That solution is at 2, -16. Notice 2, -16. The same as the what you got x equal to, got y equal to. That's the ordered pair for where they cross. How of that? Make sure that's right. When we come back from lunch, your assignment will be on the screen, and that's the first section we've got for this particular stuff. So page 431. Let's do page 463. Okay, so that gets you some that are both one solutions and then the other cases as well. Out of that, that's what I need out of that. Okay.